Hello everyone. Today I going to show you the how to create a logistic regression model. I will try to explain each step simply way so that you can understand what actually you are doing. And also at the last I will explain the result. I mean the behavior or characteristics of the generated model. So let's start. I start with the one just notebook I've created. So let me explain one by one each block. You can see it is a one notebook, Python notebook. So in the first block, you can see we just importing libraries as well as the sample data set. Today I am working with the lone default data set with the 5,000 rows. In the our previous example also shown you the example of loan default data set, right? You can see this is a data set. The column is age, monthly income, credit score, loan amount, employers, loan default. Actually, to make this tutorial very short, I'm not discussing about the how to remove the unwanted features. Okay, how to select the good feature, how to standardize values. Okay, not showing in this tutorial. Here I am just taking the uh, good, you can say good data set kind of. No unwanted column present in the data set to make our tutorial very simple. So let me run the first block. You can see it is a data set, the sample value. We just printing that df.head. It is the df is a pandas. I actually converting the CSV data into data frame, and the head function shows the sample data. Now let's explore the data. You can see age has 500. I mean there is no missing values, and all values are integer. And as I explained previous lecture, that is model can understand integer value. So if there is a string value is there, we need to convert into integer. But as I said that we have taken the good data set. That's why we don't need it. I directly jump to the train model and test it. Here's the statistical view like mean, max, and also outlier also not such outlier is present. Okay, not outlier is present bit, but it will not impact. So and also printing the how much data for every class. Loan defaulter 0 and not defaulter is count is more than the defaulter. Okay, so data is not equal, so it will affect the definitely it will affect our model performance because values dataset are not equal for each class. Okay, now we're going to split, scale, and train the dataset. So first we are going to separate the features and target variables. So before that, uh, actually state the features like here the feature is age, monthly income, credit score, loan amount, and employer. These features. Okay, we should consider these features, and we should drop the loan default column because this is answer, right? This is our target, and we keep the loan default in the y axis. So in the x axis we keep the all the features except or column except loan default, and in the y axis loan default. Now splitting the data set. Here is a code. Okay, this is the code to split the training dataset and the test dataset. And we are doing the feature scaling because as we can see in dataset, different value column value is in different range or scale. Loan default is also not default. Employee years is like this value. Loan amount this, but you can see credit score is very big value. Okay, so before training or test, we need to make all data set in the same scale as I discussed in my previous lecture, so that the value becomes reduced to between 0 to 1, so that all the values looks like same range scale or same range. So that's why I have used the standard scaler function we have created, and now feed transform do the actual transformation, standardization of the value. As these are our features, all the features in the X dataset. That's why only X10 data set we are scaling the values. Okay, but one thing, we should not use feed transform in the test data. Whatever transformation doing on the 10 data set. During the test, we should pass the raw data. Should not scale our data set. Okay. To stop the biasness of the model, we are doing the scaling. But in training testing, we don't need to care about this. We will uh, we should work with the original data set. And you can see in a test data set for the x-axis, we only using the transform. What transform does transform actually calculate the not calculate, it uses same mean and standard deviation learned from the training data. Sorry, I have done one mistake. Like in the feed transformation, what I have done first, it calculate the mean and standard deviation, and then scale the data based on the standard deviation and calculated mean value. And when do the transform of the test data set, so we are not again calculating the mean and standard deviation. We actually use the same mean and standard deviation from the 10 data set and do the transformation, so that all the transformation in this in the same within the same scale. Because if we use new uh, mean or standard deviation, so our transformation of the each feature will be different. Because basically we use a calculate Z score for each value. So Z score for the same value in the text train and test value will be different if we recalculate the value. So that's why uh, we use the same value, test and training. Okay. Now we are creating the logistic regression. So that's why I forgot one thing. That's why we have used transform, not the feed transform, because feed transform transform actually mark here. Feed calculate the means and standard deviation and then transform. But if you only use a transform, it will uh, use the existing calculated mean and standard deviation. As we are using the same object of the standard scalar, so in the first stage, whatever we calculated is actually stored in the object. Okay. Now we are creating the logistic regression model. So this is a logistic regression function. We actually importing this from the scikit-learn linear model, and the max iteration is 1000. Okay. Actually, iteration means it just automatically iterate until it find the optimal weights of every features. Okay. So 1000 is the optimal value. Now as we have created the model base model. Now we are training the base model using the fit function. X10 and Y10. We are passing the training data set. We are actually passing the features and also the our target value. Okay. Now model 10. Now predict the class levels. We just testing it. Like so, we are using here. We are use predict function and pass only the our features, so that it can predict the target or level, whether it default or not, 0 or 1, this kind of thing. Okay. And now after the prediction, we have the predicted result within the object model. So now from the data set prediction, we just selecting the probability only for loan default class 1. And also we are printing the accuracy of the model using this function. Also classification report, like it will print precision, recall, Epson score, support. Okay, all these things. Actually, it will help to you to uh, uh, understand how your model performs, how good your model is. Also print in the ROC-UC, AUC, and also finally print the weight, and also print the bias. Weight is actually uh, what is the actually importance of the each features to predict the level, how it's the contribution, how all the every features important. Okay, based on this, weights are assigned. So let's analyze the output. So first we have to need to run this block so that it train and test, and finally it prints the output. Okay, so you can see accuracy is 0.689. Also print the precision recall reference scores for class 0 and plus 1. 0 is, I mean, not defaulted and defaulted, like this. Also printing the accuracy, micro average, accuracy like for micro average, weighted average, ROC value, and these are weights for each features, and finally the bias. These are ROC curve, means the plot true positive rate versus false positive rate. I mean positive level 1 versus positive uh, sorry, this is true positive rate versus false positive rate, and positive level means 1. Okay, let's explain this output. Okay, how you can identify how good your model is. Okay, let's discuss. So in the output you have seen that accuracy is 0.689, means your model accurate 68.9% accurate. What does mean? Out of 1000 test customer, for example, the model correctly predicted 689 customer and predicted incorrectly 311 customers. Okay, formula is accuracy, correct prediction versus total prediction. Okay, example, actual yes and predicted yes, okay, fine. Actual is no, also predicted no, it's fine. Actual is yes, but it's predicted no, which is wrongly. Actual no and no, like this. Okay, so here correct prediction is 3, right, and total is 4, so that means accuracy is 75%. So is 68.9 is good? We cannot say, because it depends. For loan defaulter prediction, accuracy alone is not enough. Why? Suppose out of 1000 customer, 950 are good and 50 are default. Okay, if the model predicts everyone is good, then accuracy is 95%. It looks like amazing, but it detects zero default, right? I mean, very poor model. You can say model to nothing, but here accuracy 95%. If you check only decide only based on the accuracy, you will be very wrong. right? Understood? Because here you can see 95 are good, only 50 are very less are default, right? And your model never predict the default, only if it is good. And so in that case, obviously, as a 95 is good, around sorry, out of 1000, if 95 are good, so they obviously automatically 90% correct, right? So that's why accuracy alone is not enough. So that's why we need to another parameter like precision, recall, and score, F1 score. So for precision, as I shown you that here it calculated precision for recall, F1 score support for 0 and 1. Okay. So let's discuss the precision. You can see precision for class 0 is 0.69 and class 1 is 0.54. What is precision? Precision answer whenever the model predict a class, how often is it correct, right? So class 1 precision 0.54 means whenever the model predict lone default is correct 50% of the time, remaining 46% are false alarm. Imagine model say 100 customer will default, according to 54 really default and 46 don't default. That's why that means precision equals to 54. Understand? And what is recall? Recall means this is the most important, obviously. Recall for class 1 is 0.04. What is recall? Recall answer out of all customer who actually defaulted. How many did the model successfully find? So here actual default is 313. Model data is only about 4%. And very 4, right? So meaning out of 100 defaulter, the model find only 4 and missing 96. This is very, very poor. Why is it dangerous? Imagine a bank, actual bad customer is 100, but model gets only 4, means 96. Obviously, the bank lost some money. That's why recall is very, very important. And come to the F1 score. F1 score here is 0.08, very poor, low. So first, what is F1 score? F1 score combines the precision and recall. If neither one is poor, F1 become poor. If either one is 4, that means F becomes 4. In your case, the precision is 54 and recall is 4. Precision is not terrible, average, and recall is very poor. So that's why our threshold of F1 score is 0.8, very poor. Okay. Now coming to the support macro average and weighted average. The support here class 0 is 687, class 1 is 313 as per our output. Okay. The support column. So support simply means the number of actual samples. 687 customer did not default and 313 customer actually default. And macro average is this. Macro average means treat both class equally. Calculate matrix independently and average it, no matter how many samples each class has. Useful when classes are imbalanced. Okay. And weighted average gives more importance to class 0 because uh, class 1 is higher than this. This is sorry. Class 0 is value is larger than the class 1. This is usually reported for overall model performance. Now ROC-AUC, it gives us 0.63. Okay. first we have to know what is ROC-AUC. Actually, ROC-AUC measure how well can the model distinguish default from non-default across all possible decision threshold. Actually, it distinguish it indicates how model distinguish two classes based on the different threshold. So actually, when model gives the probability of every class, and then we have some threshold. Based on the threshold, we decide, okay, this predicted value belongs to the this class A, and otherwise class B, like that. Okay. So here ROC-AUC calculated based on the different threshold, and it calculated true positive for true. As I said before that, let me show you. True positive rate and false positive rate, and draw a plot of TPR and APR. I mean true positive and false positive. And as I shown you, this is the plot. Okay, and AO3 area under this curve. Okay, ROC actually this is a graph, and AUC is the area under curve. Understood? Again, I'm saying ROC is the curve and AUC is the area under the curve. Okay. So if ROC value is 0.3, that means random guessing. If value range between this poor to fair, if this then good, and this very good, and above 0.9 is excellent. For our case, the value is 0.62. So that means this falls within this, that is poor to fair. Okay, so slightly better than random. So what is ROC? Do you know the full form? ROC means receiver operating characteristics. Actually, this word comes from the World War II, the historical word, where actually army has some receiver, actually which receives the signals and need to identify whether the signal from the enemy or not. Okay, based on some threshold, they decide whether this belongs to the this signal is from the enemy or not. Okay, so here we are actually say the same kind of thing based on the different threshold for calculating the false positive and true positive rate. Okay, so now the weights. What is weight? As I said, these weights are actually correspond to the each feature. For age here, this one. I mean, older customers slightly less likely to default. Monthly income, how? Weight is one. Higher income reduce the defaulting. Credit score, better credit score strongly reduce the default. Loan, larger loan increase default rates. Employers, longer employee reduce the default rates. So positive weight increase the probability of class 1 on loan default, and negative means decrease the probability of class 1. Okay. And next bias. For our the bias is minus 0.87. Think of the bias as a starting point before any customer information is considered. Okay. So bias raw score or Z equals to bias plus age into weight plus into weight, like so on. If all features values are 0, a prediction would start from the baseline score. So overall interpretation is like the credit score is the strongest indicator against the default. Larger loan increase the likelihood of default, and higher income and longer employment reduce the default risk. And weakness, the model has recall is because of 4. That means almost all the customers who actually default. It's very risky. For bank, that's a serious issue because the model approving many risky customers. So how we can improve it? By classification threshold, use class work is balanced. Okay, perform better feature engineering. Okay, collect more informative feature, more powerful model like random forest or like that. So that's all. This is overall the metric. So that's all for today. And in next lecture, come up with new things. Keep watching my learning. Thank you.